you can answer that. Which carbonate species, and you need this diagram here. No, yeah, this one. Yeah. Where is it? The carbonate. Didn't I just do this? Yeah, it's right here. It's right here. Obviously, the information is here. Which carbonate species is present at the highest concentration at pH 7? Is it this one, or that one? So you should be able to answer this now relatively easily. I gave you a lot of explanation, hopefully. I hope I did a good job. I'm not so sure. Yes, I'm sure. Oh, that's so that's A, that's B, that's C. 1 is A, 2 is B, 3 is C, 27 is Z. You can, no, it's not discussion time yet, isn't it? No, but that's okay. All I want you to learn, that's all I want. Yeah, I think we're getting there. We should be. Let's see how many percentage. 36, okay. I agree with you. It's B. Some of you need to think a little bit more about the concept, but you will get there too. So this was, now I put the water in. I'm being a good man here. I put the water in, okay. So H2O plus H2CO3 is the first equilibrium. So if I'm at 6.37, what is the concentration, the ratio of this compared to this? What is it? 1 to 1, is that right? Okay. If I'm above this, 6.37 and 7 is above it, so I'm having more of this here, okay. Now, this one here, if it doesn't play any role, in order to, 7 is much below that, that means I'm on this side, there is this proton is still on here, that means that here is 3 orders of magnitude difference in pH, so it doesn't play any role. So this plays the role, and with this here is your major species, and this is the answer, okay? So we are very dependent. We means our system, our body is very dependent on quite a few buffered pHs. One of them is our blood. It has to have a very, very accurate buffering of the pH. Our blood has a pH of 7.4 plus or minus 0.05, 5/100ths of a pH unit. If this is off by more than 5/100ths of a pH unit, you are in trouble. You don't feel well at all, okay? So what we do, we breathe in oxygen, we put food, lots of it into ourselves. The food, in the end, it goes through many, many cycles, but at the end, it combusts to CO2 and water, and we get the energy from that, okay? And the CO2 we breathe out. And the CO2, you see, that's a buffer. And this is part of our blood buffering system. And if you look at it, for example, our lungs keep the partial pressure of CO2 at 40 torrs, or 40 millimeters of mercury. That's what you do when you do normal breathing, 40 millimeters of mercury. So that CO2 dissolves. Remember, that's a heterogeneous equilibrium. The CO2 dissolves to H2CO3 in water. So this is 1.2 millimoles. 1.2 times 10 to the minus 3 molar is the concentration in your lungs, okay? This makes H2CO3, all right? That's what is in your blood. The lungs provide this, and that's the concentration in your blood. It's regulated over the lungs. Now, we also have to excrete some of this CO2, not only by breathing, we excrete it through the kidneys. And there is an enzyme, it's called carbonic anhydrase, and this enzyme breaks down the HCO3 and is responsible that it gets disposed of through the urine, okay? And this concentration is 24 millimolar, 24 times 10 to the minus 3 moles, and if the concentration gets too high, the brain says, I gotta go, all right? Get the concentration down again, you know? And so this equilibrium, essentially that's the buffer system. One is the carbonic anhydrase, and the other one is the partial pressure of CO2. Now, you ever seen a person hyperventilate? They breathe very quickly. So what they do, they don't get enough oxygen in, but they're breathing out their CO2 too fast, way too fast. So what happens is that their CO2 partial pressure drops to about half of it, to about 20 torrs. With this, they are sort of disturbing the whole equilibrium. That concentration goes down, goes really down. And if you look at this here, that's the pH, that's the pKa. The pKa for this is, what was it, 6.37. But if I put 6.1 here, why do I put 6.1 here? Because that pKa is, or the Ka is temperature dependent. And our body doesn't have 25 degrees Celsius, but it has what, 37 degrees Celsius. And with this, the Ka is, say, the pKa is 6.1, all right? So now I take this here, and this was, what was it initially? It was 24 millimoles. Divided by 1.2 millimoles, okay? 24 by 1.2, what is that? Anybody can calculate it quickly for me and take the logarithm? Anybody? Come on, your DI 5000, somebody gotta have a DI 5 billion here. Okay, what is it? No, the logarithm of this, what's the logarithm? Anybody? Coming up. 1.3, 6.1 plus 1.3, it's 7.4. How clever we are. 7.4 plus minus 500. That's your blood pH. Now think about that person who's hyperventilating. Let's just assume that drops to 20 torrs. And let's just assume, we have that number here, okay? We say you do now 24 divided by 0.6. 24 divided by 0.6, and take a logarithm of it again, please. What's that? 1.6, 6.1, and 1.6. This is 7.7. You are in serious trouble if you hyperventilate. In serious trouble. What you have is alkalosis you have, okay? Hyperalkalosis, it's called, because it comes from you breathing too fast out your CO2. What do you do with a person that hyperventilates? Run as fast as you can? No. What do? You let them breathe in what? In the paper bag, all right? What happens? They're breathing quickly in their paper bag, like this, and so now they're breathing their own CO2 back in. There is, of course, oxygen coming through the paper bag, because otherwise they would be even in bigger trouble. And so with this, the CO2 pressure comes up again, the partial pressure of CO2 comes up to 40 torr, and they feel better again and they start hyperventilating. I used to be a pilot and I used to fly with my wife. She's afraid of heights, and I used to go from Brunch to Mendocino, fly up there along the coast, and there are these coastal mountain ranges, not mountain ranges, foothills there. And so in the summer there's a lot of turbulence. So the little plane goes up 20 feet and then it goes 20 feet down, it goes up and down, up and down. And so people who are not too fond of being high up, they sort of panic. And my wife says, I have to get out of here. I said, yeah, of course. We landed in 5 minutes. Next airport was 45 minutes away. Okay, we landed in 5 minutes. The problem is that these little planes, they have this dual control. If you have somebody panicking next to you, they start grabbing these controls, and there you go. All right. So first of all, what you really have to do, you have to knock them out if this comes. That's actually true. So you have to think about this. But I wasn't that brutal. I took a paper bag, which you always have in your flight case. You breathed in the paper bag, and then she came back. It was fine. And then so after a couple of minutes, she asked, "Didn't you say we're going to land in 5 minutes?" I said, "Yeah, that was just to calm you down." All right. So please use a paper bag. If you use a plastic bag, you kill that person because they are breathing in the plastic bag. No oxygen is coming in there. Okay. They're breathing their own CO2 and nothing else is happening, and so they get even in more trouble. Paper bag is the answer. So let's talk about amino acids. Amino acids, they form proteins, and these proteins folded, unfolded. You've seen these beautiful structures. They're totally folded up, and they have cavities where certain ions can go in there, and others can't. And so they do a lot of different functions in our body. And I just want to show to you how these charges of a amino acid in the protein will fold it or unfold it. Now, if you have an amino acid, it has an amino group and it has an acid group. That's why it's called amino acid. It has also other groups. And several of these groups are acidic. They have protons that can dissociate off as a function of pH. All right. So if you have an amino acid and you have a carboxylic group, there's a COOH. That H goes away, so it becomes negatively charged. And then you have another group that is negatively charged. Now you have two negatively charged groups on this protein, and they see each other, so they start unfolding because of the repulsion, the Coulomb repulsion. Okay. This is one of the many mechanisms of unfolding. But so amino acids, you have to look at this. So this is, as I said earlier, this is an acidic proton. That's an acidic proton. And amino acids, they have the amino group is always an NH3+. It's always NH3+ at certain pH. So let's look at this cysteine. That's obviously a has three protons that can dissociate the off. All right. So the first one is that's a carboxylic acid, COOH. So that proton, if I'm at pH of 0, is that proton on or off? On, exactly. It's on. So these are MCAT questions. Okay. This is on. So what would be the overall charge? If this is on, the charge would be +1. So I go to pH 4. What is the proton on or off? What's the overall charge? The net charge. 0. Very good. Always have in mind that's how the amino group comes. Okay, the amino acid. So now we go this one. So this one is off. This has a pK of 8. Of course, I could write this here. I'd write the pK here. pK of 8. I'm going to go to a pH of 6. What's the charge on this? What's the charge on this? The net charge. pH of 6. So this one is off already, isn't it? So that's negative. Is this one off at pH 6? No, it's not off because you're below the pKa of that proton here. It's not off. Okay. And so if I go, what's the overall charge then? 0. Okay. Now I go to pH of 8.5. 8.5. Is that on mostly or off? Off. What's the overall charge now? -1, exactly. So now I have that third proton here because amino has 5 electrons, the nitrogen. So I have that proton here. So this is pKa 9. Is that if I'm at pKa, if you just look at this group here, the amino group, is this at pH of 8? What's the charge of that group? pH of 8. pH of 8. What's the charge? Plus, positive, okay. pH of 10, what's the charge? 0, exactly. This proton came off, it leaves the negative charge behind, but that's NH2 than this, okay? Now you have other proteins. Yeah, no, we're not there yet. You have other protein, other amino acids. Lysine is another amino acid. Same thing. Remember, there's always this positive, is NH3+ here, okay? Even if it's not written. This is the carboxylic acid, so that has a pKa of 2.2. pH 1, is it on or off? On, so that would be not negative, okay? pH 10, what happens? pH 11, let's say pH 11. What's the charge of pH 11? If I go to pH 11. This one is 0, this one is 0, and this one? No, there's only one protein. One proton, not protein. What is this here, the charge? At pH 11, what's the charge? Negative. Of course, it's off, all right? So at pH 7, what's the charge? Is this the proton on or off? And this one? On or off? On. So what's the charge here with the proton on? And here? Okay. And pH 7 is the proton on or off here? Off. Okay. So that means this neutralizes. You have a +1 charge. Is that right? Okay, good. Tyrosine, you see that there's always this NH3. Now you have aspartic acid, pH 7. There's pKa 2, pKa 10, pKa 3.9. pH 5, what is the overall charge? No, pH 7, what's the overall charge? The overall charge is 1, exactly. -1. This neutralizes, and this is -1. Okay? And this is histidine, so I'm going to make an experiment now. Karen will make an experiment. So we have, when you eat, your body produces peroxide, H2O2. That's an oxidizer, an oxidant. And so you have been told by your health food store, use a lot of antioxidant food, all right? And so one of these food, antioxidant food, is this beautiful, what is it called? Turnip, you see? I feel better already. It takes away my H2O2 in my body. It will take a little while, of course. And so I eat, of course, you need to eat that also mostly raw, the food, because otherwise it will destroy some of this. And so we're making a little turnip cocktail here. Who brought the rum? Anybody? Rum? So, actually, it's very good. And so the turnip cocktail, this has an enzyme. This is called peroxidase. Peroxidase, it destroys the peroxide, the hydrogen peroxide that you produce in your body destroys it, peroxidase. But this only works if that solution is buffered. In your system, that has to be buffered, so your body buffers that. If it's too acidic, that enzyme doesn't work. Or if it's too basic, that enzyme is destroyed. It doesn't work. So also, in order that your enzymes work, a certain pH for the specific enzyme has to be kept. Now we're looking at this here. And here we have both of them. You put a little indicator in here. We just want to show it. We don't do a titration. And here you put in what? This water. This will be water. And this will be acid, yeah? So you see acid is red here, yeah? So we are about to destroy that enzyme here. But with the water, it doesn't destroy it. The buffer will be working. And so now if you put hydrogen peroxide, H2O2 solution in there, we should see a reaction where that H2O2 will be taken apart by that enzyme to H2O and water. Remember we had this many lectures earlier. We destroyed H2O2. It made with a manganese catalyst. It made H2O, water, plus oxygen. So let's do that, and let's see which one works. There you go. There's your enzyme. This one we destroyed here because the pH is not right. But this enzyme, beautiful. I hope it doesn't happen in your body that fast, okay? You will be floating. You will be floating. But this enzyme here, it destroys the H2O2 and the oxygen comes out and makes these bubbles all. And with this, you know now how to eat, that you have to eat lots of antioxidant food, okay, to get a lot of these good enzymes. I think Karen left. We can't give her any applause, but let's walk a little bit, exercise a little bit. Exactly. So let me ask you one final question. What is the, and I haven't drawn the charges here. I told you about this, so you guess that's the typical MCAT question. What is the total effective charge on the amino acid cysteine? These are the pKa's. On the amino acid cysteine, I have not drawn the charges, okay? Remember, at a pH of 5, is it +1, is it 0, or is it -1? Let's see what you got. I can guarantee you that similar questions coming in MCAT. Those of you who are planning to take it. So are you in? Let's click in that we are not running over. And I will not discuss it the next time. Next time we do something totally different, new chapter. I may discuss it in our review sessions. Okay, everybody in? Yeah, let's stop it. Let's see what the answer is. I got you, unfortunately. So what is this here? It is that NH3, there's a plus needs to be there. Then NH3 has a plus. There, that's how it should be written. I said I didn't put the charges on it. NH3 has a plus. We have pH 5. So that pKa, that means it's off here. That's in the acidic form here, that nothing happens here. And this one is nothing happens here, that stays on, that's SH here. And this one here is off, isn't it right? In the base form. With this you have, what is the charge? Plus and minus? The answer is 0. Okay? Alrighty, good. See you on Monday.